Right, thank you, Lucas. And thank you, everyone, for being here at GDC Dev Series. I'm super excited for today. So today we're going to explore how procedural rigging and deformation has been shaping character workflows in a AAA production and how EA Sports has been leveraging Bifrost in a real production environment as well. Before we get started, though, I just want to do a quick pulse check. Is everybody familiar with Bifrost? Have they been using Bifrost? If you are familiar with it or have been using it, please type Bifrost in the chat so we know who you are. And the next question would be if you have been working on any games or developing any games with a lot of high-end characters. And if you are, please type EA in the chat. Looking forward to see your answers, but thank you for participating. So before we do dive into EA's presentation and look at their workflow, let's quickly look at what Bifrost is. So Bifrost is a node-based visual programming tool for procedural 3D content creation. And this tool is available inside of Maya. With Bifrost, you can create environments, you can do simulation, modular rigging, procedural animation, and more. Bifrost is also very well integrated with Maya USD and with Arnold inside of Maya. Additionally, Bifrost can be executed outside of Maya and can also be integrated with other DCCs using very powerful Bifrost SDK. In short, it's a procedural framework for building pipelines, for building systems, like procedural rigging system you'll see. Bifrost offers a fully modular and procedural motion system that includes all kinematic parts of the rig: skeletons, constraints, IK solvers, and a lot more. With procedural rig, you're not locked into a fixed structure. You can add and remove joints as you feel in a joint chain, change proportions of a character skeleton, or even add number of limbs if you want to a character, all without breaking a rig or losing your animation. So as you can imagine, these workflows can be especially powerful in production environment where iteration and speed is a necessity and variation and non-destructive workflow really matters. Instead of rebuilding the rigs every time, now you have a system that kind of evolves with you and helps you do things really fast. And as you can see in this video, you can also do procedural animation with Bifrost procedural system. Like shown in this video, a character follows the aim constraint and it changes and it adapts to the terrain as the aim changes. And with the latest edition and the latest version of Bifrost, you can now also build an entire rig by connecting modular components. And we do provide example components like arm, legs, spine, tail, etc. you see on the screen here. We also provide a full biped template to get you started. So you really don't have to start from scratch. You have modules to get started with. But that's really just the foundation we provide. The real value lies when studios are able to take these modules, customize them, and standardize them, and use them in their production pipeline to fit their needs. And this is where EA's story was really interesting for us. And even before we introduced these specific Bifrost modules inside of Bifrost, EA was using Bifrost deeply in their deformation workflows and building compounds to leverage procedural workflow inside of rigging. What Darren is about to share is just not about using these templates. It's about how procedural rigging can help streamline workflows, specifically when supporting large multiple productions in a studio. Now, it's my pleasure to introduce someone who's been pushing the boundaries of character deformation and procedural rigging at EA. Darren Rudy is a principal technical architect or artist focused on rigging and deformation within character animation research team. It's called the A-Team. The A-Team explores cutting-edge technology across animation, physics, machine learning, and that technology powers realism in franchises like NHL, UFC, and a lot more. So today, Darren will walk us through how they use Bifrost, not just as a tool, but as a foundational infrastructure in their rigging workflow. Darren, over to you.
Thanks, Samara, and thanks, Lucas. All right. So welcome to my EA Sports Character Deformation with Bifrost presentation. I'm going to go over how and why we use Bifrost to rig our EA Sports characters. It's a quick introduction of me. a little more than was already said. So my title is Principal Technical Artist, Rigging and Deformation. I work on the A team. And I've been at EA for almost 21 years, and I've been rigging the whole time. And an example of titles you see on the screen here has what I've been worked on in my whole tenure at EA. So of course, FC, UFC, NHL, Madden. So yeah. But first, before I show you how exactly we use Bifrost, I just want to give you a bit of our problem space for some context. Which will be the Sapien initiative. So quickly through the problem space, we wanted more shareable deformation because for EA Sports, we work on these, physical specimens, these athletes, and they're in all these games, and we wanted to better share work across our games. We wanted more iterable deformation through robust workflows. So we just wanted, to iterate more through tools and stuff like in DCC tools, which of course would lead to improved deformation and while keeping it character performant for runtime. So that's the problem space. So it's a pretty big problem space for us. And then the Sapien initiative was born to address this problem space. So it has three main goals to address this problem space. We wanted a common EA Sports skeleton in structure and position. So position being relative to a proportion and morphology. So if you think of like an elbow on one mesh and proportion and an elbow on another mesh and proportion, when you looked at the elbow, you would expect the joint to be in a similar space to both of those, even though they're different shape and potentially size. So how we did that was for like a single game, like you see this GIF on the right here, we have a constraint in our games where we want one animation skeleton for the whole game. So, and this is an example where we wanted to better represent the male and female gender. So we come up with like this example to get a unisex skeleton. So what you kind of see here is you're imagining these are two different, very different morphologies. And by morphology, I mean shape of the character. But you can imagine they have the same underlying skeletal structure or proportion. So we're like, okay, let's get that to best represent these two very different morphologies. So that's what we did here. We wanted improved high quality deformation, of course, like in the problem space that was runtime performant and of course easier to author. So just quick little image here of like amount of joint count we can have in our games. So this is like the amount in the Sapien skeleton. So if you don't have good tools and workflow to author these, that would be a lot of work. And of course, shareable deformation, the big one. So looking at this from like the EA Sports franchise perspective. So at the top, we have Sapien. So we do all this investment in making this deformation look good. How do we then better share it? So like we share it, we integrate into FC. But let's say FC then, invests their dollars on improving the characters and deformation. We want that investment to be leveraged across EA Sports, not just for FC. So we wanted a better way to share that. So deformation's a little harder to share than like a model or something like that, or textures. So we needed some systems and tooling to kind of help with that, and foundational foresight like the common EA Sports skeleton. Okay, so one other piece of context to keep in mind when I go through all the presentation and slides is Bifrost doesn't run in game. Okay, we only use it for our rig authoring in Maya. So this little kind of flow you see, we have this rig description. So that's like the rig, how we describe it. It doesn't need a DCC. We have it like externalized. And then the Sapien process here into Maya, that's where we use Bifrost. And that's kind of where we can build from this description, or we can write to this description. And you can see from the Sapien process, we also go to game. I'll explain more what we use in game later, but this is the context that to keep in mind as we go through this presentation. Okay, so let's look at how we use Bifrost. So some visual cool stuff now. All right, so we have a raycast joint placement tool. So what you're seeing in this GIF here is adjusting some parameters, like angle, orientation, and length and rate direction. These are parameters we adjust to position the joint, and we're using this Bifrost board, and you see me jumping into the compounds here, where we're raycasting that joint and positioning it on the mesh. So why we do this? It's to do with our shareable deformation across, between two different morphologies and meshes. So we have this sports skeleton that's positioned relative to a mesh as we would expect. So if this is consistent, we could then parameterize our secondary joint placement by ratios to that. So we could have 50% between the clavicle and the arm joint. Okay, that's the middle. If we know that direction and we shoot in this direction, we'll roughly hit the trapezius pretty well on any morphology. And that because proportionally, the character's trapezius will be where we expect. So adjusting these parameters would have been a very big pain and then waiting to see the position results. So we're able to get this in real time and interactive by using Bifrost to do that. Deformers. So for deformer R&D, we use Bifrost. So in this case, we're using Bifrost to do some jiggle. We use vertex colors, and then we export these vertex colors to our game engine, and which Frostbite in this case, to see, like a mesh or a mesh-based jiggle. We don't tune 100% of the values in Maya. We get a good rough idea, but it's mainly for authoring the maps that where we want the jiggle, how much it should jiggle in these regions. This is where we tune that. So we found it very easy to kind of use Bifrost to do this. So yeah, pretty useful. Another deformer prototype we have here is blendable skin weight. So what you're seeing in this GIF that's not a corrective shape or anything. What we're seeing is a small or skinnier body type blending to a larger body type using the weight file from the smaller body type. You can see it doesn't kind of hold up on that bigger body type. So what we then do is we blend to a different weight map for that bigger body type. So of my pen here. So you can see here on vertex 80, these are the influences 0, 1, 2, 3, etc. So I'm selecting on influence 1 here. And you can see for weight map 1, it's like 0.425 for the weighting. And then on weight map 2, it's 0.362. So what we're doing is we're blending between those weight values and using Bifrost to do so. So this is pretty quick, and we're blending 31,000 verts each tick. So that's what you see here. Cool. Physics volume fitting. So we use Bifrost to, better fit our EA physics volumes. So what you're seeing in this GIF here, these little points, these represent a primitive volume, and they're mimicking our EA physics volumes. So in this case, it'd be a capsule and a fat box. So you can see in the GIF here, we're kind of just adjusting like parameters like radius, half dimension, length, etc. So these these are essentially mimicking EA physics volumes. Okay, so how are these used? So right here, where I'm laser pointing over here, you can see these green dots. So these are raycast out onto the mesh. And those are the Bifrost, like if I go back, that's what these are. They're raycast onto the mesh. And then we use these new positions to kind of calculate a new average radius, length, etc., to drive parameters. What you see, these little orange capsule-like things, the wireframes, those are our EA physics volume representations. And then on the GIF on the right, I'm adjusting the mesh, and we're seeing the physics volume primitives be adjusted while the mesh volume changes. So this is it's not 100% real time here. It's got a bit of a delay, but we don't ever actually author it like this and kind of just showing you this is like more of a pipeline step. But we can visually verify our pipeline's working by doing this step. And so yeah, we're able to kind of fit physics volumes, and we can constrain how we fit them with this. Like, oh, we don't want to move it, we don't want to rotate it, we can only adjust the radius. This allows us to kind of control how we can fit our physics volumes in our pipeline. And our biggest use for Bifrost is driving our secondary joints, or more simply, pose space deformation. So right here, I'm just moving the arm joint around, and you can see these secondary joints. They're moving, like doing some corrective rigging, moving some muscles, just so we can get some, more realistic deformation. Another example here, isolating the arm. So I'm just rotating the arm joint here, and you can see the bicep joints, triceps, all that sort of stuff, doing correctives so we get more realistic arm deforming here. So I'm going to go into next how we use Bifrost to do this. So we have these graphs set up where our concept is we have a driver graph, In this case, these are Bifrost boards or graphs. I'll probably say board and graph intermittently, like interchange those. But these graphs are here. We got our driver graph, our pose graph, and then a secondary base graph. Our secondary base graphs are kind of broken into like regions, and those are arbitrary. They could be whatever. In this case, shoulder, could be arm, whatever you need. That's or whatever we need, I should say. Yeah. And then there's also like a shader graph here. Not it's more of a, it's kind of a pass through. It's like the secondary base graph, but we sometimes do different things where we might want to drive a blend shape or a normal map with a different different values than we would from the pose graph than we would with like driving joints. So it's kind of a nice little extra layer for pass through, and in that shader graph we can drive anything external to this in game. So let's go into each one of these graphs in more detail now. So the driver graph. So here it is in the node editor. So what we're reading is we read in like a matrix. In this case, it's like left arm driver. It could be anything. It could have been the left arm directly, but we just have a group, constrained group that we bring into this. So we're bringing in the driver. And this is a simplification as well. So that's that. So there's the driver graph. Let's step into the driver graph now, or board. So on the left here, you can see that rig I was showing earlier with the arm and the scapula moving. This is like all the drivers we would have that exist in that rig. So these are all they're coming in, and then we've got inside each one of for each driver we do what we need to do for a driver. The drivers can be anything. We can constantly be changing this, making this up. What do we need to kind of make a skeleton position the values more useful for us to do something with? That's really what this concept is. So this case, we're going to step into like a swing twist compound, which is our driver. So inside the swing twist, you can see, okay, we got our ins, our matrix, and we got a multiplier and our output. So we're going to step into our swing twist compound even further. And this is where you can see where this is where we do our swing twist decomposition and do the, conversions and stuff to get the output value we need. So I'm going to jump into the swing twist decomposition compound, and too much to show in kind of in one area, but you can see this is where we start doing all of the swing twist decomposition. So yeah, it's kind of layered complexity, and I'll talk more about that as this presentation goes on. Now we go to our pose graph. So usually the driver graph goes into the pose graph like you saw earlier. In this case, I'm showing where we have our driver swing. The output of our driver, we actually route to a transform, just so we can better select it and when debugging the rig and work with it. You do take a performance hit for doing that, but it didn't bother us because it didn't matter. Yeah, so in this case, we can go from driver graph to pose graph, but in this case, I'm going driver graph to transform to pose graph. And again, this is a simplification of the pose graph. I'll show you, you'll see like non-simplifications later. Speaking of non-simplifications, on the right here, this is an example of like a pose graph. So you can see the amount of poses in that rig is quite extensive. And then the simplification here inside the pose graph, where it's really what we're doing is we're taking a driver value, in this case, driver A, and B, between A and B values, so between 0 and 4.83, we want to remap that to 0 to 1. So we're kind of just doing a normalization step here. And you can see when we jump into that, it's some simple normalization, and then we get our output. So that's kind of what the pose graph is. It's taking so all these driver values, let's make them more descriptive, user-friendly poses to describe what your skeleton is doing. And then from the pose graph, we go into our secondary base graph. So our secondary base graph, for every pose input, it also has an equivalent transform. So in this case, like we've got for a joint, our deltoid intermediate 001, and these are the arm adduction, arm extension, flexion. Those are the poses for that. If they come out of the pose graph, we have an equivalent transform. So you can see here they are in the node editor. Again, this is simplification. And then here they are in the outliner. And then over here on the right, this is an example of like the size of the pose graph going into each secondary base graph. So like this one's expanded, so you can see it's quite massive. And I'll show that a little bit later too. So it'll make more sense hopefully later through the presentation. So yeah, into the secondary base graph. So we got all our poses. We call these fractions going into here, these pose fractions, and then the matrix, the pose matrices and the parent matrix, everything you kind of need to go into our blend matrices compound. And you can see for this right here, this is like the full inside, a full complete one of that rig I showed you. Essentially, each one of these blend matrices represents a joint. So for every joint in this region, we have to do this. So let's jump into, in this case, we're going to jump into deltoid intermediate blend matrices compound. So we jump into that, and this is where we take our inputs and we iterate on it. And then we just convert our value to what we want outside of our iteration. So we're going to jump into the iteration. And this is where we do our interpolate matrix using our fractions. And inside the interpolate matrix, you can see I'll jump into like this linear interpolate translate. You can see this is where we do all that to get our matrix result between these pose percentages and these positions of these transforms. So it might be a little confusing here. I'll show a simplification next, but kind of what I want to say at this slide is it's really, what we found really useful was the layered complexity, stepping through this. So having each kind of step be this compound was really organized. It was very organized for us to better, to get into Bifrost or the rig itself and figure out what was going on and grow on it and improve on it. So this is a simplification. So this is broken on purpose. This is not good deformation. But kind of what I was showing in those previous slides, this is an example of that. So we've got a joint that's blending between, for the poses, it's blending to each one of these locators that I showed. And those are on the outliner in those previous slides. You can see like, arm extension, arm flexion, it's blending between those. And it's never always, when you're going through an animation, it's never at a pose, it's always at a percentage. So I'm moving a few of the locators so you can see it's always blending as a percentage of the poses that are active. Here's an example of what the simplification you saw, but actually with an artist workflow. So we can say we can go to this like forearm flexion pose. And now can I instantly select one of those transforms that are going into the Bifrost graph, and we can interact and move with it right away. So it's live tuning. So like at this pose, and we can start, just moving the animation and seeing we can tune it. We can kind of show you all those locators. Like, so all these locators are for all these joints have that pose, and you can see we can adjust it. And I'm actually not even adjusting it at a pose here. I'm off a little bit. So you're seeing the interpolated result between multiple poses while I'm moving that locator at this frame. So yeah, just the kind of, then this over here, this is like the glimpse of our Sapien workflow for authoring. It's joint based. How else so a shareable repository. So this right here, we kind of have, this is where we store our compounds, and then we store some Python code for our wrapper code. And this right here, this is where you can see the amount of compounds we have. So we extensively use it, we're constantly making compounds for everything. Every time we come up with this new feature, whatever, that's okay, this part will be a compound. And you can see here, and this is in Bifrost, you can see we got our little A-team section, Sapien, and then we got it organized by type. You can see all of them show up here, so that we can just interact and access this very easily when we're working on our rig. So I talked about the code. So this is where we have our VNN wrapper code. So highly recommend this be done. This is, I showed some of the complexity of those rigs, earlier. Where it's like, obviously that was generated by scripting and coding. That wasn't manually done. So a lot of our code is like, we did a nice wrapper, so it's much easier to read and debug. So yeah, and that also exists in this Bifrost, this shareable repository that anyone at EA can use. All right, now I'm going to show some visual examples. So this is the rig functioning and working in FC. So you can see this is kind of a test bed level. So this is in Frostbite, and we're just seeing the deformation happening. So the rig is working here. Okay. And then another example of that. So same deal, but it's in a lineup, so you can see very performant. Lots of stuff happening. That we got the full 2 teams in a lineup with all the other stuff happening too, all of our other cloth and stuff happening on top. All right, so I showed you how I set up some context. I'm going to go more into like why we did this. This is kind of like from the game developer perspective of like where this helped us. So let's do some more history and context on why. So Sapien, we first shipped on FC24 and Madden 24. Um, so we did the aligned Sapien skeleton between those two titles. And we built the rig with traditional Maya nodes. So we're at that stage. And then, okay, so we finished these two titles. We're like, whew, okay, we shipped. Yay, celebrate for a second. Now think, what are we gonna do next year? So postmortem, what worked, what didn't, what can we improve? Right away, we knew we were going to have more adopters. So what must change? We can't do everything we need to do. So we came up with our refactor plan. And the main thing that we settled on was we wanted more rig maintainability and rig extensibility. So at this time, we were like, okay, well, Bifrost seems cool. Let's see if this is useful and will help with this maintainability and extensibility. So we were able to quickly re-rig that the MyNode rig in Bifrost. I think it two to 3 weeks. It was very quick. And we're like, wow, everything was exactly the same. Like numerically, we were able to like do layovers and like, yeah, this is very cool. And we're starting to see like, okay, this is there's going to be some benefits to doing this. So I'll talk about the benefits throughout this whole part, but I do need to go to Bifrost to Rigamate parity. So remember that I'm going to call back way to earlier in the slides when I showed, we had the rig description and then we had the Sapien going into Maya and then game. This is how we get it into game. We have a tool called Rigamate. So it's in Frostbite. So what is it? It's Frostbite's node-based authoring tool to read and write transformation data. So this UI you see right here, this runs in Frostbite or Maya. So we can actually just create these nodes through here and get them working in Maya, and all the nodes that exist essentially. And it has an API too, so which we'll use on Sapien, where we don't need to create the nodes through hand. We can do it through the Rigamate API. So we do author this in Maya, and then we export something called a Rigamate graph. And this Rigamate graph we import into Frostbite. So to simplify this as much as possible, essentially what you do is you read a joint, you do stuff with that changing value, and then you write to another joint. So that's kind of the concept of this. Um, the Maya node graph was very complex. So when we're talking about Bifrost to Rigamate parity, we're like, well, we need to compare what we had, which was Maya nodes. And we're like, wow, these are complex. And as we were doing this, we were like, okay, this is like we call this like a quad diff driver. You can see the Maya nodes in the middle, then compared to the Bifrost board on top, and then on the bottom, that's how you would in the dependency graph. That's the Bifrost board here, and we were like, wow, this is just easier to read in general. We were just starting to notice like the Maya nodes were way more challenging to debug than Bifrost. Also, Maya nodes were nothing like Rigamate. In this example, we have like an arc cosine or an ACOS. That didn't even exist. I don't know if it exists in earlier, newer versions of Maya, but at the time, it didn't even exist. So we were even missing basic math nodes that we needed to do this. And we were like, wait, Bifrost and Rigamate has that. Oh, that's convenient. And then when we started looking even more, they're very similar. Like we were able to recreate a lot of what existed in Rigamate in Bifrost and get numerically identical results. Here's an example of a Catmull ROM 5 node we have, just like as the driver changes between these domains, make something move through this curve. Yeah. So we were able to recreate that, like, oh wow, okay. They're also very similar in structure. So like a board, this isn't exactly how it is, but it's close enough to kind of call it out and have a laugh at it. But a board equals a graph and a compound equals a subgraph. It's very similar to that. And this image, which you see here, this is inside a Rigamate, where we have our driver graph, pose graph, and our secondary base arm. And we have this in Bifrost. And they're essentially identical. The exact same names, the inputs, outputs, everything, just in different environments. So right away, we're like, wow, we're recreating this stuff in Bifrost. This is going to simplify how we, create our Maya workflow and our output to game. They're very similar now. We're going to have less code and less difference. And Rigamate and Bifrost, luckily, were same Axios handiness and row major for matrix calculation. So no conversions. We're like, yeah, we're just kind of lucky. And we're like, hey, luck here is this, take luck when you get it, right? So we're like, this is great. This is working for us. So I have to kind of like say, well, why not use just Rigamate only? Rigmate's awesome. It really is. We were able to do a lot of we do a lot of cool stuff. We still use it, but it's we were struggling to make like an intermediate authoring rig. So when you saw me moving those locators and you're seeing the actual adjusted rigged results in real time there happening, that was a little awkward. It was awkward to do in Rigmate. It was a challenge. Essentially, because Rigmate was built optimal for runtime performance. It's a Frostbite tool, which is it's a Frostbite tool first and a Maya tool second. So it's amazing at what it does. So we kind of end up at this spot where we're like, okay, um, Bifrost is really well integrated and similar to Rigmate, and it's in Maya and it leverages all that. So it's really cool to build workflows on, and artists are familiar with it. It's very integrated very well. And then you have over here we have Rigmate where it's like built optimal for runtime to build if a full sports team, 22 plus players running in real time using this. So it's built for that first. So we kind of get the best of both worlds here. And now I'm going to kind of for this, I'm sharing a button, but this button was very useful for art production. So importing compounds into a scene. So what that allowed us to do was like we were allowed to share scenes like a rig with like complex like that would have like a Python plugin before or something. We were able to like do mimic that stuff, but just import it into the scene. And then you didn't need an environment and dependencies to share that between other people. So that was very useful for us. And anyone else watching this in big productions, like you might probably have that problem where, we need the tool environment for this game or this game or this game, and all these environments and these dependencies. And it's hard to share content if they're relying on those. The dependencies are unique to each one of those environments. So this solved that problem for us from the rig's perspective. So we could very easily view and validate across domains easily. So we could view an FC rig in a Madden environment because we just import the compounds here. Check it out. All you needed was Bifrost running in your, and obviously the plugin loaded in Maya, and that's it. And it would just work. So that was very, very like one button, but I do want to call that out. That was a surprising advantage to us. Why Bifrost? Of course, we had to end up with less code. So we were doing code to compound where it makes sense. So an example of I was talking about the complexity earlier. So obviously we do a lot of code, but like our code is more so building the structure. It's building the graphs, imports, inputs, outputs, plugs. We're kind of building the structure. And then when you get to what the rig is doing, that's a compound. So you could just get in there and you rig with your hands, but then you could build the rig with code. And the hand part was compounds. And that we found that really, really useful because you can see this is extensive. Like this is zooming in on that. And you can see here's all the poses coming out into the secondary base graphs, for example. And here's like all the poses. So yeah, we found that breakdown, that organization was very, very helpful. And another thing we found super useful was the ability to debug a rigged state. So like what I mean by that is, okay, you built your rig, you can just, it's not working correct. You can just jump into that compound, import it, and just start tweaking and fixing right there. That was super easy. And then you save that out and then you just rebuild again, or you don't need to. It's working in this case, but if you rebuild it again, it'll be using that compound. And that was very, very handy for us. So like it's like before when we in the Maya rig, we're just editing the rig through code and then building it and checking. So it gave us this more hands-on step to debug and rig with. So like obviously this trade-off proved way more stable and efficient for us. Like efficient, we can like iterate and improve on this more. It was pretty nice. And yeah, it was stable, uh, very useful. So in summary, Bifrost empowered Sapien and shareable deformation. Bifrost empowered rigging artist tuning workflows to get on these complex rigs. So essentially, Bifrost empowered an enterprise rigging solution at EA Sports. So we have future improvement plans. So we're going to migrate to a more recent version. So we're actually even on an older version of Bifrost. There's so much more cool stuff to use that we can't wait to get our hands on. We want more user interaction and tunability with the rig, and we definitely believe Bifrost can help us with that. We want to do more like pretty stuff with the viewport, like controllers and stuff, and view cues for artists and stuff like that. Just when you're interacting with the rig, you get more feedback from it. So we'll be looking at Bifrost to get that from it as well. And of course, as we're doing this, we're always going to be working on rig speed and optimizations because we're going to just throw more and more at it. We're going to do more cool deformation, and we need speed and we need optimizations. So yeah, all done. Thank you. That's my presentation. I believe I'm passing it on to Lucas.
Yeah, thanks, Darren. This was really, really great. Thank you so much for sharing this, and I hope everybody in the audience enjoyed it as well too. Now we have time for Q&A. So basically, yes, if you have any questions, please drop them in the webinar chat, or there's a Q&A box as well too. Should be at the bottom of your screen. So please drop them in there so we can get to all of your questions. And I'm actually already seeing one come in through from Hernan. So this is, what is one of the areas that you guys would like to see improve in Bifrost? And I guess assume this question is more directed for Darren. Yeah.
Um, it's like an interesting question. Um, I have a trouble time asking that. Maybe off the top of my head, I was talked to this with a colleague at work the other day. So his kind of more his idea, but he mentioned quickly like changing iterators to whatever type instantly. Just convert it to while or whatever. Just like that would be kind of nice, just to do that instead of having to recreate it and put stuff in it. Just change what this iterator is doing. It's like an iterator container that can be all these types. That would be kind of useful. Um,
Nice.
yeah.
Great, nice. Yeah, and I also actually I do have a question as well too, on my side at least. So looking ahead, you did mention improvements around turnability and rig performance. So what is a rigging pipeline still painful today, and what are you hoping Bifrost will unlock next?
So what's still painful is still getting something into game. It's a challenge. So and we're gonna be you definitely leveraging how can we make Bifrost and Rigamate work together better, essentially. So it's um, we think we have some other ideas we want to do in this space, but it's making sure getting stuff into game is seamless as possible and tooling around that. So that literally can be all still in Maya, where how we export it, how the rigs contained, all that sort of stuff. But really just closing anytime you need to convert data from one step to another, making that as seamless as possible. So we'll definitely be using Bifrost in that space.
Nice, thank you. And this is a question coming through from Alan. So speaking of performance, were metrics gathered after the Maya conversion to Bifrost to compare, contrast how evaluation times looked? Was there a noticeable difference?
Oh yeah. So honestly, it was as simple as turning the frame rate counter on and watching it not be 4 FPS anymore. It was that simple. It was instantly 60 FPS. It was very snappy. So that was kind of, we didn't have to do anything complex. It wasn't that, nothing fancy. It just was, you could feel it. You could literally feel it. Yeah.
Nice, great. This is also a question coming through from Diane. Hopefully, I'm saying that correctly. Sorry. Those rigs look very processor intensive. How do you ensure that the characters run on all platforms?
Lot planning. So, um, obviously not all platforms can run everything, so you kind of have to plan for what level of detail from the rig. So we can load our rig being like, we want this output to skip these joints. No, it's literally just this joint will be secondary driven or this joint won't be. And we can map it to which LOD has that accessible. So it comes down to loading because yeah, you can't run, they are extensive rigs and they can't, not every SKU, I call it, the Switch versus, PS5, they're very different. They can't run the same thing. So we plan for loading ahead, and the rig is fully loadable. So good question. I didn't even bring that up, but yeah, we plan ahead for loading.
Great, nice. You also talked about shareable deformation across, the multiple productions that you work on.
Mhm.
Can you give an example of like where that really paid off in
Yeah.
production?
For sure. I mean, that was probably the biggest win from the Sapien initiative from my perspective. It was also cool visuals and stuff. I love all that too. But for me, it was like, wow, being able to share this deformation was a win because it was like a goal of mine and a challenge of mine too, just to do that. So an example is we work on, the FC24 title and we just, invested and made it look as best as we can. Madden started from that just by a click of a button, right? We transfer it over. So before there would be like, okay, how do we get this deformation over the skeleton? We change that. We were able to really simplify that process. And then you can build, and then Madden can build on that, right? And then because of this process we built, Madden can then roll back into FC if they want. So kind of that was a pretty big win from as far as an organizational perspective, where we were sharing content, expensive content to create quite easily. And there's still work to be done as it goes to each thing. Is the button and click is like there's still some artifacts. It's not 100% magic, but yeah, it's very, very useful.
Great. Yeah, thank you. Great answer. Also, so from an artist perspective too, how did moving logic into compounds instead of code change your day-to-day workflow? Did it noticeably speed up iteration or any debugging?
Definitely debugging. Like iteration was and iteration too. So focusing on debugging, like it was just you could when you build your rig, you're working on the rig, you get intimate with it, you really understand it. You're like, oh, this is broken. You look at this thing, you just map your way through these compounds and be like, it's in here somewhere. And you just kind of intuitively know that. I mean, you do that with code too. You build your rig or whatever. Yeah, it's probably in this, in this module over here. But I found like it was much easier just to jump into the rig, like because you're interacting in this 3D world instead of this code world, and you can just immediately get in there, import it, and start tweaking it. That to me personally was a better workflow. It felt more artistic, and it felt like you didn't just, there was less hope. Build, hope it works. You were just right in there and be like, oh, it just broke it. It's just broken, and then you could fix it. So yeah, and then the iteration. So iterating over that, like same type of deal. You were able to just jump into the compounds and iterate and improve instead of having to kind of write code to do that all around it. It was like, I wouldn't say it was like a huge, oh my God, crazy difference, but it was enough to be like, I don't want to do it the other way again. Right. It was a win. To quantify it as like, yeah, it was worth it.
Perfect. Yeah, thanks, Darren. We do have another question from the audience. So besides rigging, are you looking into integrating Bifrost into other areas of your workflow?
Since I only rig, I can't speak for anyone else. I would say I'll be working with other domains that are open internally at EA. If they want any advice on Bifrost, I give it openly on how, and I look at their problem space and be like, here's maybe how it can help. So for me to answer that question, I'd be like, first, like, what's your problem space? What are you struggling with in DCC and authoring and the content? And where is the Bifrost, like basically the way you can, contain complexity. That's a good literation. That's what it's good at for productions for us. Where can that contained complexity empower you and solve your problems? So I would kind of approach it as a question first. Can't say I am doing this anywhere, but I would work with someone who maybe wants to leverage this from that.
Great. Yeah, thank you. Yeah, I don't think I'm seeing any more questions come through from the audience, but as we're closing it, if I see any more come through, we can definitely get to those. So please feel free to drop more in, everybody, if you're still having any questions you want to have answered. But before we do close out, I do want to say a huge thank you to Darren and Samira for coming on, sharing more about Bifrost, and I hope everyone learned a bit more about how they can use Bifrost for games and for their game projects for rigging. I will actually launch a poll. So this kind of lets us know if you would like to be contacted by somebody from Autodesk to learn more about Maya or Bifrost for your game workflow. So please answer that poll if you'd like anyone from our team to reach out. And I'll invite Darren and Samir to say, I guess, a few closing words before. Actually, sorry, I just caught a last question, so I will get to that first because we do have some time left. This one's from Evgeny. So if you don't mind sharing, how many people were involved in developing this workflow at EA? Looks like a group of geniuses.
So directly on my team, there was 3 people, and we built most of this. But when you get to an organization of, like EA, you're standing on the shoulders of giants, as they say. So there's a lot of you could say there's whole other domains that we built off of and learned from too. So building the tools directly, it was a team of 3. But we got to leverage a lot of amazing work that had been done by other people all over the company.
Nice. Yeah, thanks, Darren. I'm seeing more questions coming through actually. So we have a couple more to close off with, and this one actually for you, Samira. So are there any development updates on the roadmap to keep an eye for in the near future? Anything that you're excited about that you can share? Feel free to hop on if there's anything on your mind.
Yeah, the only question you asked me, I can't answer the future questions. We are actively working on rigging still. You can see improvements even in the last beta. I can talk about the beta improvements. I can't talk about what's on the roadmap. But keep an eye. The beta drops almost every 2 weeks, and if you look at if you download the beta or are in the beta community, you'll see very progressive updates in rigging and in other domains as well. Sorry, I can't answer roadmap question directly.
No, all good, all good. Perfect. Thanks. Yeah, thank you both for hopping on. This is really, really great. Yeah, I guess I'll invite you both to add any closing words before. Oh wait, sorry. Actually, I keep on saying that, but there's also questions coming through at the same time. So actually, there's another question here as well too. So what advice would you give to someone who's proficient in Maya modeling but has not touched Bifrost before? And I guess this could be a question maybe for both of you if you want to go first, and maybe Samir, do you want to jump in first on that?
Yeah, so Bifrost, like you saw in rigging context, is built to do anything procedurally inside of Maya. Now, we don't provide a lot of out-of-the-box modeling tools per se inside of Bifrost, but there's enough for you to get started with. It's as simple as if you're modeling something inside of Maya, you want to do some procedural operations on top of it, or add some functionality like Boolean, for example. You could do that inside of Bifrost for retaining the proceduralism. Again, not a lot of out-of-the-box built-in tools for procedural modeling yet. But like you saw with Darren's presentation as well, there's a lot you can build because the building blocks would be there for you, and you can build your own compounds as well.
Cool, perfect. Yeah, thanks, Samira. There's actually a typo actually in the question. They meant noding, not modeling. So I'm not sure if that adds anything differently.
Okay. Yeah, it completely changes the answer. Yes, it completely changes the answer. We do provide a lot of graphs to get started with. So if you open Bifrost, there's two tabs. One is Bifrost Graph and one is the browser. Browser comes with, I think right now there's over 70 different graphs. And you can type into your own domain, like if you want to create effects or you want to go rigging. So for example, our module is something we provide with. So you can open it up, experience it. There's notes inside it to tell you what each compound does, or if there's a new node, what it actually means. So there's a lot of in-app information you can learn from. So if you're new, I would suggest don't build a graph from scratch. Start with a browser graph, and that's the easiest and fastest way to get started with.
I mean, I can answer my perspective too. It's like we did exactly that. We have built this full Maya rig with Maya nodes, and then we converted it into Bifrost. So the answer is like have a node network that you have and be like, I should convert that into Bifrost. Something starts simple. And then you'll start to see where it starts. Bifrost kind of leads you down the path of making compounds and layering and going in and like layering it. And you'll start to see your long node graph in Maya becomes these nice containable compartments of logic.
Nice, thank you both. So I'm seeing another question come through from Evgeny. So how was the skinning done? Was it manual, or did you develop any auto skinning tools using Bifrost?
So we didn't. The answer is both. There was procedural skinning and there was manual skinning at the end. A lot of manual skinning for fine tuning through the art direction process. But we did start with procedural skinning too. Now, we didn't use Bifrost at this stage for the procedural skinning. We were just using 100% coded. Just getting our verts and iterating on them and doing that. But yeah, it was a bit of both.
Great. Yeah, thanks, Darren.
Yeah.
I've seen another question come through actually that I missed earlier. So I'm not sure if it's coming from a 3ds Max user actually. So they're asking if you use Maya because you prefer the rigging capabilities in Maya from something you've used in the past, or is there do you have a preference that you've seen between the rigging capabilities in either software?
So I haven't used Max since it was like 3D Studio back in the 90s. So I have been a Maya user. So like for me, it's a familiarity thing and it's what our productions used. So really I can't, I can't answer what's better in A or B for those two packages because I'm not familiar in Max at all.
Yeah, no problem. Thank you. I'll do a final call as well for any more questions. I keep trying to transition and I'll see more come through. So hopefully, if anyone has any questions, please drop them in. I want to make sure, since we have a few minutes left, that we get to all of them. Okay, great. Nice. All right. Well, is there anything else as well too? We will be sending the recording to all of you at, like I mentioned earlier, after the event. Oh, sorry, I'm seeing another question pop through. It's no funny every time I close off. It's hilarious. So would you rather just straight code or visual coding?
Um, that's funny. That's a funny answer. If I were just like depends on your environment. In Maya, you want to do both. But if I were to say, I'd rather just straight code, to be honest, in a lot of ways, because it's like, well, you got all these AI assistants helping you now. It's getting easier. Coding is just kind of like merging and all that sort of stuff. It's really nice being in that space, but like yeah, in a 3D environment where I'm interacting with something like, like an animator would, it's both. I will always code and I love to do visual programming. Can't say one or the other.
Nice, thanks, Darren. One last question for me too, actually. Since Rigamate and Bifrost are actually pretty similar conceptually, like you were saying, did Bifrost make it easier for you inside of Maya, or was there anything easier inside of Maya that Bifrost could do that Rigamate couldn't?
Yeah, it's existential, like make being interactive because the dependency graph, the way Bifrost is integrated in that right there makes it so we can interact with everything in Maya constraints. We could just kind of like we could use every part of Maya into getting into Bifrost. With Rigamate, it wasn't as simple as that because it's a whole external environment that we're kind of using transformation space to go into, do stuff, and come out. So interacting with Maya and building workflows around that was a challenge. So yeah, that's why Bifrost is, it was more DCC like tuning friendly environment. So that's why. Yeah.
Perfect. Thanks, Darren. Nice. Yeah. So thank you everybody for joining. I think this was really great talk, and I want to extend another huge thank you to Darren and Samira. And apologies for everybody for the bit of the back and forth on the close and the questions, but I'm glad that we got to answer everything that you had asked. And yeah, I'll invite Darren and Samira to add a few closing words before we close off.
I just want to say thank you. As a product manager, it's immense pleasure to see our customers use our product in this way, and in fact, taking it beyond what we, provided from out of the box. And it's really a pleasure to see EA adopt this and showcase it in this way and inspire other game studios as well. So thank you, Darren.
Yeah, thanks. And for me, just thank you to everyone who came to check this out. I wanted to share this stuff just so other people can see kind of like how useful this is. It's it made our game, it helped us make our games look the way we wanted. So definitely should share that.